All right, so first thing we want to do in this case, on a problem like this, the first thing that we're going to want to do is make sure, I forgot that, yes, OK. In this case, first thing we want to do is make sure we group our variables. So obviously, guys, this does not look like the equation that we just had up there, right? And that's easy. When you have it like in the denominator, you can find a squared, you can find b squared, right? You can find the center. It's kind of easy, isn't it? I mean, once you have it in that format. Finding a, b in the center. Yes, no? You guys didn't think it was that easy? I thought it was pretty easy. This is not in that format, though. So what we need to do is get it in that format. So to create binomial squared, we have to complete the square. First thing we want to do is group the x's with the x's and the y's with the y's. You don't need to put the 42 to the other side, but in my opinion, that just makes everything much easier. So I like to go ahead and put the 42 on the other side. Do you guys see how my x's are grouped together and my y's are grouped together? Yes? OK. The next thing, when we're completing the square, if you guys remember, you can only complete the square when your quadratic term, the term that's being raised to the power of 2, has a coefficient of 1. So here you can say this has a coefficient of 3, and that has a coefficient of 5. So what I'm going to do is we're going to factor out those values. Does everybody see what I did? Is everybody OK with what I did? Alyssa, does that make sense? Good? Daniel, you good? Feel good? OK. Now we complete the square. How do we complete the square? We got to find the value c that creates the perfect square trinomial. So to do that, if you guys remember, we take b divided by 2 and square it. So our b is our coefficient of our linear term, which in this case is -4 divided by 2 squared. -4 divided by 2 is -2. -2 squared is 4. Over here, we take our b, which is our 6. 6 divided by 2 squared equals 9. Now, we add those terms into both of our parentheses. So the first one would look like this. 3 times x squared minus 4x plus 4 plus 5 times y squared plus 6y plus 9 equals -42. Is everybody following me what I've done on the left side? Because remember, whatever you do on the left side, you have to do on the right side. So be careful, though, because we didn't really add a 4 on the left side. We added a 4. That bidistributive property is also being added, multiplied by 4, or 3. So you add a 4. That needs to be multiplied by 3. You want to add a 9. That needs to be multiplied by a 5. Now, again, what's nice, at least about completing the square, guys, is if you complete the square correctly, you just created a perfect square trinomial. That's really helpful because they're easy to factor down because they factor down to binomial squares. So x minus 4x plus 4 factors down into x minus 2 times x minus 2, which is just x minus 2 squared. Y squared plus 6y plus 3 can be factored down into y plus 3 squared. Then here, 9 times 5 is 45. 45 minus 42 is 3. 4 times 3 is 12. Plus 3 is 15. Yes? Here? Just factoring. What two numbers multiply to give you 4? Add to give you -4. So it's the same. So since they're the same, we just write it as x minus 2 squared. OK, now, again, do we even want it in this format? No, we want to. So now we have x minus 2 squared equals 3 over 5 is 5 plus y plus 3 squared is 3 equals 1. So now it's in this format. Again, we kind of like it in this format because can we easily find out what a squared is? A squared has to be 5. B squared is 3, right? And then you could even do c squared. Hopefully you guys know c squared is square root of 2. Does anybody do that in your head? Yeah. If not, let's just label them. A squared is equal to 5. So a equals the square root of 5. B squared is 3. B then equals the square root of 3. C squared, remember, is a squared minus b squared. So it's 5 minus 3, guys, right? That's how I got that so quickly. So c equals the square root of 2. Now, but again, that's not even what the question is asking. The question is asking what is the center, the vertices, the foci, the covertices, right? We did all of this work, but we haven't really answered one question yet. So first thing we need to do is find the center. Center in this case is 2, negative 3. I would prefer to graph this. 2, negative 3. Now, let's go back to where's this major axis? Is it vertical or is it horizontal? That all depends on where a squared is, right? So based on a squared being under the x, my major axis starts with an h, rhymes with horizontal. Horizontal, yes, very good. So we know my center. Now what's important about that is, guys, again, that means your vertices are going left or right, right? So why that's important is I'm not even going to sketch the graph here. But what I want you guys to understand is if you're going left or right, from your center, should you add your vertices to the x-coordinate and subtract them? Or should you add and subtract them to the y-coordinate? The x. Do you guys see how that makes sense? If you add and subtract to the x-coordinate, that's moving it left or right. That's where your vertices are on your major axis. They're left and right. So my vertices are going to be 2 plus or minus the square root of 5, negative 3. Let's just do the foci next anyways, since the foci is the same thing. Foci is going left and right as well. Foci is square root of 2. So I'm going to do the same thing, just do it with the square root of 2. And then the covertices are the other way. The covertices are going up and down, right? So I should add the covertices then to the y-coordinate of the center. Because remember, covertices are as distant c, or b, I'm sorry, from their center. So you're adding and subtracting to the y. So that's going to be 2, negative 3 plus or minus the square root of 3. Whew. There you go. You will be assessed on a problem just like that.